Okay, so define or give the name of each of these features of the circle. Number one over here is a line that touches the circle in exactly one spot. Never enters it, but it does touch it. What's that called? Tangent. 2, what's that called? That is a radius. 3, yeah, it goes through the circle. The technical definition of a secant is it has points both inside and outside of the circle. 4, yeah, if we go all the way across, it's a diameter. It's actually a special diameter. It's called a reference diameter. Because it is the horizontal diameter. Now, when we're dealing with a circle, remember we talked about directions for the rays when we were looking at angles. This is the 0 degree direction right here. So we use that diameter that contains the 0 degrees as our reference diameter. 5 over there is something we actually haven't talked about yet. Does anybody know what number 5 is? That's a geometric structure called a sine. A sine is actually a distance. It's the distance from any point on the circle to that reference diameter. So every point of the circle has a sine. Like if I pick this point here, that's its sine. If I pick this point here, that's its sine. Notice those 2 points have the same sine. They're the same length. Pick this point here, there's its sine. Again, those 2 have the same sine, same length. There are always 4 different points on the circle that'll be the same distance away from that reference diameter. Now, only 2 of them have the same sign, because technically this point down here, even though it's the same distance away as this one, this will be considered negative because it's below the reference diameter. Over here, number 6 is this area. That area is called not a segment, sector. A segment would be if you had a chord that you just cut off a little thin slice. 7, that piece of the circumference is called a arc. And 8, that angle in there is a central angle. Very good. Kind of, because this is the stuff that we're going to be learning about today. These are the things that actually define trigonometry. You know, everybody thinks of trigonometry as being about right triangles, and it's applied to right triangles. 99% of the time, that's where it gets used. But trigonometry is actually from a circle, and we're going to try to do a better job of drawing a circle than that. There, pretend that's round. It's actually a very special type of circle called a unit circle. What do I mean by a unit circle? Means the radius of the circle equals 1. Now we've talked about that reference diameter briefly. A reference diameter is the horizontal diameter that just cuts across it. It contains that 0 degree point. Now I'm going to put in a vertical axis as well. We tend to think about this unit circle as being on our graphing coordinate system. So there's vertical and horizontal axes and coordinates to deal with. We're still more concerned about the features of the circle itself. So now, this 0 degrees, this part right here, is often referred to as the initial side. Because everything we work with is going to start from that 0 degree edge there. And as we rotate around the circle from that, we actually rotate counterclockwise in this direction. And actually, let me go a little further so I'm not right in the middle like that. Let me go right here. That angle there is a central angle, but it is also the angle that we are going to be working with. We'll actually refer to it as a reference angle at some point coming up. We'll notice that side that we've created with our central angle intersects a point on the arc of our unit circle. That is the point of interest. So I'm going to put an angle in here just so we have reference here. We're going to call that a 30-degree angle. Most of the time, we're going to refer to that as angle theta. Theta is just like X, Y, or Z. It's just a Greek letter. It's just when we tend to refer to angles, we use Greek letters for variables rather than English letters, rather than our Arabic numerals. Theta, just like that. So now that point on that circle defines some features. The sine of that angle is the distance from that point so we're going to call that the sine of our angle theta. In this case, it's the sine of 30 degrees. So you'll notice that sine is one of our three main trig functions. Next, we're going to talk about tangent and secant. Those, excuse me, we have to kind of talk about those together. Tangent, our point of tangency is always the reference diameter. So here's our point of tangency. We go from that point of tangency up until it intersects the terminal side. You know, if this down here is the initial side, this is called the terminal side of our angle. So this comes up tangent here until we intersect that terminal side. Well, that distance that I just created there is the tangent of our angle. And then, of course, we extend that terminal side out until it intersects. Well, that terminal side now has points that are inside the circle and outside the circle. It is a secant. That length is the secant of theta. And that defines our three main trig functions: sine, tangent, and secant. And of course, tangent forms a right angle to the radius or the diameter, so that's a right angle there as well. This forms two very, very important triangles for us. First off, this little triangle in here. That little triangle, this is our angle. We know this side over here is the sine of that angle. We're going to abbreviate it just SIN. What do we know about the hypotenuse up here? From here to here. What's the radius of a circle? 1. Yep, so that hypotenuse is 1. We're going to come back to this bottom leg down here in just a little bit. Then we have a larger triangle that's formed. This one here. That's similar to that triangle. This is the same angle. This is a right angle. This side over here is the tangent of that angle. This up here is the secant of that angle. And the bottom down here is from here to here. That's just the radius of the circle, which is 1. So there's only one side here that we haven't defined. That's this bottom side of this triangle here. Well, I said these are our three main trig functions: sine, secant, and tangent. But if you look at your calculator, what does your calculator have? Cosine. So where does that cosine thingy come from? Cosine is actually a prefix in a main word. It is cosine. The co prefix means of the complement. What's a complement? We talk about angles, complements, do what? Add up to 90 degrees. Good. So if we look up here, if this is the angle we're looking at, where's its complement? Right there, right? That's a right angle. Those two add up to 90 degrees. So when I'm talking about a co-function, I'm talking about the function of this angle, the complement of this angle here. So that angle there, it would have a sine. What that does now is that means this is now the reference diameter, because that's the diameter that our angle is going off of. The sine of that point, or of that angle, would be from here to here. Does that make sense? Going from our point on the circle, because this is still our terminal side, going from our point on the circle to this reference diameter, the vertical reference diameter. When we have a co-function, we use this axis as the reference diameter now instead of the horizontal one. Because this angle here is the complement of whatever this angle is here. Those two have to add to 90. So that would be a cosine. A cotangent would be this tangent up here. Cosecant is that secant there. So this is the cosecant, and this is the cotangent. Notice they still make right triangles. But more importantly, for our concerns here, this makes a rectangle, doesn't it? And in a rectangle, opposite sides are equal. So if this is the cosine, this distance to here is also the cosine of our angle. So that means down here, this side of that triangle is the cosine. So we use cosine as one of our main trig functions, only because what that does is allows us to keep everything within this one small triangle. And when we look at trig identities later, we're not going to use them in depth, but we're going to look at some of them. It's nice to have them all within the same triangle. So a lot of our trig identities involve sine and cosine together rather than sine and secant together. So before I go back to that triangle and start defining stuff, if I tell you that the cosine of 60 degrees is 0.5, what's the sine of not 60, but 30 have to be? What's the relationship between 60 and 30? The one's double, but they also add up to 90. They're complements. The cosine of 60 is equal to the sine of its complement, right? The complement of 60 is 30, right? So if the cosine of 60 equals 0.5, the sine of 30 has to equal 0.5. Because the cosine of 60 is really asking what's the sine of the complement of 60? Well, the complement of 60 is 30, so the sine of 30 has to be the same as the cosine of 60. If I tell you that the sine of 60 is 0.866, what's the cosine of 60 have to be? Sorry, not the cosine of 60, cosine of 30. 0.866. Good. Because 60 and 30 are complements, they add up to 90 degrees, the sine of one has to equal the cosine of the other. Which tells us there's only one angle where the sine and cosine have to be equal. Can anybody tell me what that is? What angle is its own complement? 45 degrees, very good. Sine of 45 degrees and cosine of 45 degrees. Wow, I'm off this morning. Sine of 45 and cosine of 45 have to be the same because they're complements. It's its own complement. Back up to these lovely little triangles up here. If I want to start looking at similar triangles, if I want to try to define the sine here, what I'm going to do is I'm going to compare it back to this side here, its hypotenuse. So I've got sine over 1, sine of theta over 1. What side of the other triangle corresponds to the sine? Tangent. What side of the other triangle corresponds to the 1? Secant. That's actually an identity. The sine can be found by dividing the tangent by the secant. We can look at the cosine, comparing it to 1. What side of the other triangle corresponds to the cosine? Here's cosine, and the other triangle, that would be the 1, right? What side corresponds to the 1? Well, that's still the secant. The cosine of an angle is equal to 1 divided by the secant of that angle. So the reciprocals. That's a very important one. We're going to look at that one a lot. Let's start with the tangent here. Let's compare that tangent to this side here of 1. What side of the other triangle corresponds to the tangent? The sine. What side of the other triangle corresponds to this 1? Cosine. So there's another identity. The tangent can be found as just being the sine divided by the cosine. Well, how do we find any of those functions? Let's scroll down and take a look. So we have a right triangle. Here's our angle theta. Notice all right triangles, if they have that same angle, any right triangle that has this angle theta is going to be similar to this triangle, isn't it? Because if it has this angle the same and they have the right angle, that's 2 out of the 3 angles the same. The third one has to be the same, doesn't it? So any right triangle that has one angle of theta has to be similar to this one. So that means is once we know that that angle's theta, we can compare this back to that unit circle, and we know it is similar. This Here are the ones up here. We know it's similar to that triangle out of the unit circle that we saw. It's actually similar to both of these triangles. So what I'm going to look at here is in this triangle, I'm going to define these sides. Of course, we know this is the hypotenuse, right? The other two sides are called legs. Well, to differentiate the legs, there's one leg that is next to the angle. One leg is across from the angle. We call one of them adjacent. What does adjacent mean? The word adjacent means next to. So the one that's next to that angle or touches that angle is the adjacent leg. The side across from it is the opposite leg. Now that only works if we are looking at this angle here. It's very possible to look at the other angle. If we're looking at this angle, this is still the hypotenuse, but what happens to the legs? This one would now be the adjacent because it's next to the angle we're looking at. This one would then become the opposite because it'd be across from that angle that we were looking at. So when we're looking at opposite legs and adjacent legs, their position depends on which angle we're looking at. For right now, we're looking at this angle. So this is opposite and this is adjacent. Does that make sense? You look confused, Tom. Okay. This is always the hypotenuse because it's across from the right angle, right? These legs here are called adjacent and opposite, depending on which angle we're looking at. Well, adjacent means next to. Nope. Here is the angle. If we're looking at this angle, this leg is next to it. It's touching it. This one's not touching it. It's across from it. Okay. If we were looking at this angle, this would be the opposite over here. And this one would be the adjacent. Yes. Whichever angle we're looking at determines which one is the opposite and the adjacent. So here, if I want to find the sine of that angle, I'm going to use sine of theta over 1. Here's sine, there's the 1, right? Sine corresponds to which side of this triangle? Sine and opposite. The 1 corresponds to the hypotenuse. If I wanted to find the cosine of theta, cosine corresponds to which side of this triangle? The adjacent. And the 1 still corresponds to the hypotenuse. If I wanted to find the tangent of that angle, tangent corresponds to which side of this triangle? The opposite. Now the 1 here is on the bottom, so that corresponds to which side of that triangle? The adjacent. So that means we can define the sine, cosine, and tangent in terms of the lengths of the side of a right triangle. In just a second, I'm going to give you a triangle with those lengths and we'll define those. But I want to define our other functions, the ones that we think of a lot less, like secant. Secant over 1. This is the secant. What side of this triangle does that correspond to? This one and this side, right? That would be the hypotenuse. The 1 still corresponds to the adjacent side. We haven't gone so far as to construct the cosecant and cotangent triangle, but those would also be similar. Cosecant is abbreviated like that. Cosecant corresponds to the hypotenuse over the opposite side. Cotangent is abbreviated COT. Cotangent would be related to the adjacent and the opposite sides. So it's from these similar triangles plus one that I didn't draw out that all 6 of those trig ratios, they're called, come from. And that's all any of our trig functions are, is a ratio of the lengths of sides. So let's give you a triangle here. I'm going to call this angle A and angle B. So I might call, let's see here. I'm going to make this side, get out of my way. Yeah, we'll do 8, 15, 17. Using what we did up here, sine of angle A. Sine is opposite over hypotenuse, correct? So if this is angle A, what's the opposite leg? Which leg does not touch A? It's across from A. That would be the 8. The hypotenuse, of course, is always, in this triangle, the hypotenuse is always the longest side, or the side across from the right angle. That'll be 17. So 8 over 17, which we could divide out if we wanted to, 0.4706 is the sine of angle A. How about the sine of angle B? Well, sine is still opposite over hypotenuse. But if we're looking at angle B here, which leg is the opposite leg? Which side of this triangle doesn't touch it? What's that? The 15 is the opposite. So that would be 15 over the hypotenuse is still 17. We could divide that out. 0.8824. Now you get asked, how do I want it? Do I want it as a decimal or as a fraction? And it really doesn't matter. They're equivalent. The fraction is actually exact. The decimal is going to be rounded. How about this? What is the cosine of angle B? Cosine is adjacent over hypotenuse. So for angle B, which leg is adjacent to it? The 8. And the hypotenuse is still 17. Notice cosine of angles A, or cosine of angle B and sine of angle A are the same. Why is that? Well, how do these two angles have to be related? They equal 90 degrees. This one's 90, and since a triangle adds up to 180, the other two angles of a right triangle have to add up to 90, or be complements. Since they are complements, the sine of one equals the cosine of the other. Which means we want to find the sine of angle A, or not the sine, cosine of angle A. That's just going to be the same as the sine of B, 15 over 17. Here's A. Cosine is adjacent over hypotenuse. The adjacent side is the 15, and the hypotenuse is still the 17. What if I wanted to find the tangent of angle A? Tangent is opposite over adjacent. From angle A, what's the opposite leg? The 8. The adjacent leg is the 15. What if I wanted to find the cotangent of angle A? Cotangent is adjacent over opposite. So here's angle A, the adjacent side is the 15, and the opposite is the 8. Notice these two are just reciprocals of each other. You flip it over. How about the secant of angle A? Secant is hypotenuse over adjacent. So here's angle A. The hypotenuse is 17. That doesn't worry about the angle. But for angle A, the adjacent side is 15. There's a relationship between these two as well. The secant of A is the reciprocal of the cosine of A. Just flip it over. The cosine is 15 over 17. The secant is 17 over 15. And finally, the cosecant of A. Cosecant is hypotenuse over opposite. Well, here's A. The hypotenuse is always 17 for this triangle, no matter what angle we're looking at. But for angle A, the opposite side would be the 8. Notice that cosecant of A is related to the sine of A. It's the reciprocal. If the sine is 8 over 17, the cosecant is 17 over 8. Flip it over. Now, over the next couple of days, we're going to spend a lot of time looking at these relationships as to which trig functions have to be equal, which ones have to be reciprocals, and stuff like that. It takes a while to get used to it. Because for most angles, if I give you 2 of the trig functions, you can find the other 4 because of those relationships. Let's come back here. So, how do we find these without the triangle? Well, let's just do this. I'm going to have to find a few with the triangle here. I want you to find sine of A, cosine of A, tangent of A. You can just leave them as fractions if you want to. Secant of A, cosecant of A, cotangent of A. I'll give you a couple minutes to find those. The first 3 are the ones that we're going to have to be really good at quickly. The sine of A, remember sine is opposite over hypotenuse. So from angle A, which side is the opposite side? 5. Which one is the hypotenuse? 13. And of course that would leave which one is the adjacent? The 12. So sine of A is 5 over 13. Cosine, remember cosine is adjacent over hypotenuse. So that would be, cosine of A would be the adjacent side of the 12. Hypotenuse is the 13. Tangent is opposite over adjacent. So which side's the opposite? The 5. And which side's the adjacent? 12. So those are the main ones. The other 3 are the cofunctions. Well, the secant really is one of the main ones, but we switch in the cosine for that. Secant can be thought of as one of 2 ways. Secant is either hypotenuse over adjacent, or we can think of it as the reciprocal of the cosine. The hypotenuse is 13, the adjacent is 12. And notice, if I took the cosine and flipped it over, that's what I would have. Cosecant. Cosecant is hypotenuse over opposite. The hypotenuse is 13, the opposite is 5. 13 over 5 is the cosecant. Notice that's the reciprocal of the sine. And finally, cotangent is adjacent over opposite. Adjacent is 12, opposite is 5. You'll notice that is the reciprocal of the tangent. Just flip over the tangent. So now let's look at angle B. Sine of angle B, cosine of angle B, tangent angle B, secant angle B, cosecant of angle B, and cotangent of angle B. Well, without even looking at the sides of the triangle, I know that the sine of B has to equal what? Cosine of A, because A and B are complements. Let's look at it. This is angle B. With angle B, the 13 is still going to be the hypotenuse, but the 5 is not going to be the opposite anymore. It's going to be the adjacent because it's touching that angle. This isn't going to be adjacent anymore because it's across from that angle. It's now the opposite side. So sine is opposite over hypotenuse. That's 12 over 13. Notice the definition is still the same, but the opposite and adjacent sides switch places because we're looking at the other angle. But again, you'll see the sine of B and the cosine of A have to be the same. Cosine of B. Remember, cosine is adjacent over hypotenuse. Well, adjacent now is the 5. Hypotenuse is still 13. Notice that and the sine of A are the same. Tangent of B. Tangent is opposite over adjacent. The opposite side is 12. The adjacent side is 5. Notice tangent of B is equivalent to the cotangent of A. Cotangent still means tangent of the complement. So since A and B are complements, the cotangent of A equals the tangent of B. Secant of B. Secant is hypotenuse over adjacent, 13 over 5. Now there's two relationships here. You'll notice that's the reciprocal of the cosine, but also that is equal to the cosecant of A. Cosecant of B. Cosecant is hypotenuse over opposite, 13 over 12. Now again, you notice that is equal to the reciprocal of the sine. It's also equal to the secant of A. Cotangent is adjacent over opposite. The adjacent side is 5. The opposite side is 12. You will notice cotangent is equivalent to the tangent. You'll also know that it's the reciprocal of the cotangent of A. There's a lot of different relationships going on here. How do you find them in your calculator? Let's start out with the easy ones. Sine, cosine, and tangent. If I want to find the sine of 20 degrees, first thing I have to do is go into my calculator and make sure it is in degree mode. So you press a mode button of some sort. Mine is in degree mode instead of radian mode. We're going to test that here. Sine of 20. So you hit the sine key and type in 20. Most of your calculators should go forward notation. You should close the parentheses, but it won't affect you if you don't in this case. Hit enter, you should get 0.34202. If you did not get that, that means you probably got a mode set up different in your calculator. So you did sine of 20, did you get 0.34202? Yep, okay. So then everybody's got their mode set right. Cosine of 50. Same thing, cosine, type in the 50, hit enter, 0.6428. or the tangent of 30. Type in tangent 30, you get what, 0.577? Does that look great? So those are the easy ones. Those are the ones your calculator is built to find. To find secant, cosecant, or cotangent, you have to remember they are reciprocals. Cosecant is the reciprocal of the, secant is the reciprocal of the cosine. So to find the secant of 20 degrees, we have to do this. You do cosine of 20, close the parentheses, and most of you have this x negative 1 key. Hit that x negative 1 key before you hit enter. It'll give you 1.0642. That is the secant of 20 degrees. Cosecant is the reciprocal of sine. So to find the cosecant of 50 degrees, you do the sine of 50, close the parentheses and hit that x negative 1. 1.3054. And then cotangent is the reciprocal of tangent. So to do the cotangent of 30 degrees, you do the tangent of 30 degrees, close the parentheses and hit the x negative 1. 1.732. There are a couple of pages here that we're going to work on. Actually, just page 338, 341, 1 through 73, the odds. I'm going to have to give you a new packet for this, I believe.